Let's solve some questions. In the question number 1, he is asking the electronic energy is negative because the first option is given, it is electron has positive charge. That is absolutely wrong. Now, going to the second option, the energy is 0 near to the nucleus and it decreases as we go far away from nucleus and it increases, right? Let us check whether it is correct or not. Now, in Bohr model, we studied about the energy of the electron. So, the solution of this question will be, En, that is energy of the electron in any shell, will be equal to 13.6 Z square upon N square electron volt, right? This we have already studied. Now, let's find out the energy in first shell. So, E1 is equal to minus 13.6 into Z square divided by 1 square electron volt, and that will be equal to minus 13.6 into Z square electron volt. Z is the atomic number, and why I am not taking the atomic number? Because specie is not specified here. Whether it is hydrogen or helium plus or lithium 2 plus, it is not given. So, I have taken Z as constant. So, E1 is equal to minus 13.6 into Z square. Let us find out E2. So, the value of E2 will be equal to minus 13.6 multiplied by Z square upon 2 square electron volt, and that will be equal to minus 13.6 multiplied by Z square by 4 electron volt. So, let us see what is actually happening. So, in this case it is minus 13.6 into Z square. This is minus 13.6 into Z square by 4. So, since negative sign is there, it means the energy is increasing. So, if energy is increasing, then what he is saying? He is saying that energy is 0 near the nucleus and it decreases as the distance from the nucleus increases. It means that this is not correct. Now, option number 3. Energy is 0 at infinite distance. So, let us find out the energy at infinite distance. The energy at infinite distance will be equal to, that is E infinity, that will be equal to minus 13.6 multiplied by Z square upon infinity square electron volt, and that is equal to 0. So, that statement is correct. So, that part is correct, and is saying that from the nucleus and it decreases as the electron comes towards the nucleus. So, as the electron comes towards the nucleus, energy decreases. So, it is absolutely correct. Means, if the energy at second energy level is minus 13.6 into Z square upon 4 and first energy level it is minus 13.6, we know that E2 is greater than E1, and we studied also as we go to the higher level energy increases, And what is the highest level? Highest level is where n is equal to infinity. So if the highest value of the energy is infinity, the lower value will be having the negative charge. They will be negative. It means that the option third is absolutely correct. So the answer is 3. Right? Let's solve one more question. Now in this question he is asking the ionization energy of the electron in the lowest orbit. Lowest orbit means first orbit of the hydrogen atom is 13.6 electron volt. The energy required in electron volt to remove the electron from the 3 lowest orbits. So first lower orbit he has given to us already, that is 13.6, that already has been given to us, and he want to find out the energy to remove the electron from first 3 lowest orbits, that is E2 and E3, right? So first of all we have to know how to find out the ionization energy. So what is the ionization energy? Ionization energy is the minimum energy required to eject the electron from the outermost shell to the infinite shell, or you can say to the outside of that particular species. If electron is removed from the first shell to infinite shell, or outside the atom or outside the ion, the energy required is called ionization energy. Now one more thing I want to tell you here, if you are finding the value of the energy that is required to eject out the electron from the ground shell, that is called ionization energy, and from any other shell, that is called separation energy. It means that we have to find out the ionization energy and the separation energy from E2, the shell number 2, and we have to find out E3, that is shell number 3. Let's find out first how to find out ionization energy. So the solution will be, now ionization energy of the electron is given to us, means that ionization energy will be equal to E infinity minus E1, right? E is the energy at infinite shell and E1 is the ground shell. And ionization energy is given to us, that is 13.6 electron volt. So it is 13.6 electron volt. And E infinity, we know that it is equal to 0 minus E1, that is the energy of ground state. So it means that E1 is equal to minus 13.6. Now why it is given? He want to confirm that the formula we are applying is En is equal to minus 13.6 into Z square upon N square electron volt. This formula we are using, and that's why we are getting the ionization energy equal to 13.6, right? So let's find out the separation energies of shell number 2 and shell number 3. So E2 is equal to minus 13.6 into 1 square, since it is hydrogen atom, divided by 2 square, because it's shell number 2, that is electron volt, and it is equal to minus 3.4 electron volt. And similarly, when we will find E3, we will get minus 13.6 multiplied by 1 square divided by 3 square electron volt. Solving it further, we will get minus 1.51 electron volt. Now guys, minus 3.4 electron volt is the energy of the electron in the second shell, and minus 1.51 electron volt is the energy of the electron in third shell. Now how to find out the separation energy, what is asking? So the same thing we will do for the second shell and third shell what we did for the first one, that is we found ionization energy E infinity minus E1. Now in case of the second shell, the value of the change in energy that we have to find out, delta E is equal to E infinity, means the energy required to eject out the electron to the infinite shell, minus E2. So this is the final energy, this is the initial energy. That will be equal to 0, E infinity is 0, you know very well, minus of 3.4, and that is equal to plus 3.4 electron volt. Now this is the energy required to eject out the electron from the second shell. Similarly, let's say that it is equal to delta E2. Similarly, delta E3. And what is delta E3? That will be definitely E infinity minus E3, and that will be 0 minus 1.51, and it is equal to 1.51 electron volt. So this is our final answer. So energy required to eject the electron from third shell is equal to this, from second shell is equal to this, and first shell we have already calculated, that is equal to 13.6, that is given to us, right? So our answer will be equal to fourth. So fourth is the final answer. Answer is option number fourth. Right guys, let's solve one more question.